Okay, so hello, good morning. I wish a very good morning to one and all present over here, distinguished speakers, head of the department, respected faculties, and all the participants. I warmly welcome you all once again to this second day of 5 days STTP on the design of confined machinery buildings for earthquake disaster risk mitigation in India. Firstly, I would like to apologize for this abrupt ending we had from my side at the last session yesterday. Because of some internet connectivity issues, I could not repeat the instructions for today's joining. But I'm quite glad that all the participants have shown the enthusiasm and their interest towards learning this particular subject from our experts, and they have joined on time. So without any further ado, I would like to begin our first session for second day, and the topic which we will be discussing and beginning with is the machinery materials and design method, which will be preceded over by the prominent speaker, Dr. Svetlana Brizev ma'am. Just before handing over to ma'am, a simple trend that we followed yesterday. At the end of the session, if any of the participant is willing to ask any question or query, they can raise their hand or write their question in the chat box, and your questions will be answered. So I won't take any much time ahead, and over to you, ma'am.
Thank you very much, Aditya, and good morning to everyone. For me, it's much earlier in the morning. It's about 6:30. So for me, the morning has just started, actually, but it is okay. I'm in Europe, so right now. So we will start with the first lecture. Today I have two lectures. First is on masonry materials and design methods, and I will share it right now. It's going to be about 1 hour, and then as I mentioned, it could be your questions are most welcome and discussion as yesterday. That is very important for the course and for your understanding. So I will start with sharing the lecture. The topic is very important, and as you can see in this course, not all topics are seismic related. They're all masonry related or confined masonry related, and I think even the code that we have now in front of us, new code, is covers the details of masonry materials, and so we need to cover them because in many cases students don't have background on masonry materials, and we need input information about the materials as design of confined masonry buildings. Therefore, today we'll talk about, we'll go over some of the masonry material standards, and then discuss about properties of different masonry units, clay bricks, fly ash bricks, and concrete blocks. We'll discuss the properties of mortar, and then mechanical properties of masonry. So not only units and mortar. Mortar masonry is a composite material consisting of masonry units and mortar, and in some cases, as we learned yesterday, a reinforcement in case of reinforced masonry. So in terms of Indian masonry standards, there are many of them. First of all, there is a standard on design of unreinforced masonry, Code of Practice for Structural Use of Unreinforced Masonry. And until this year, that was the only design standard for masonry, that is IS 1905. And then the rest of the standards are all related to masonry units. For example, IS 1077 is specifications for common burnt clay bricks. Then the IS 12894 is the standard for fly ash bricks, which we will talk about today as a possible, because that is a possible and feasible masonry unit for confined masonry. And then brickwork, concrete masonry unit. So anyways, I don't want to go over each and every standard, but I may mention some of them in this context, but just for you to know that these all standards are available for you to access in case you're designing masonry. I will also mention in today's lecture ASTM standard. The ASTM stands for American Society for Testing of Materials. I'm not sure if you I'm sure you heard of the society and of this abbreviation ASTM. and this is their website. So they have also a number of standards related to, let's say, concrete, masonry, and other materials. And some of the methods we will mention here. But I would say that their methods the standards are very comprehensive in terms of the description of the test setup, testing procedure, and the results, and therefore they're considered among the best in the world. And I personally always refer to ASTM standard if the standard in the country I'm using is not comprehensive. Many standards in countries are based on ASTM standards. So that's why I'm going to mention they are available also online, but at a charge. They're not free like Indian standards. So we will start with masonry units, and we will start with clay bricks, which is the most common masonry unit in India. There are two types, unburnt or adobe, and burnt bricks. I think nowadays it's not even necessary to mention that these are burnt bricks. Normally, we use burnt bricks for engineered masonry construction. Unburnt or adobe bricks or blocks are used in rural areas, in low economic sections of society, and they're not, they're just sun-dried. They're hand manufactured by communities and are sun-dried, so they cannot be used definitely for engineering systems like confined masonry. Chemical composition of clay is 65% silicon oxide and 20% aluminum oxide. And typical units, I will go over it. I'm showing just two different brick units. One is on left side is fly ash brick, and on the right hand side is clay brick. Typical clay brick dimensions in India are 9 inch by 4.5 inch by 3 inch. Length times width times thickness. It is important for you to know the dimensions of brick roughly, like this. And one way of remembering it is 3 times 2.5 and times 1. Times 3 times 1.5 times 1. So 1 is 3 inches, 1.5 times 3 is 4.5, and then 3 times 3 is 9. So maybe that could be easier to remember. So 9 inches is the length, or 23 centimeters. It will be shown on another slide as well in millimeters.
Madam, sorry to interrupt you. Your presentation is not visible.
Oh, I'm sorry. Maybe I haven't shared it. I probably haven't shared it. Thank you for letting me know. Just let me see. Open share tray, screen. Is it visible now?
No, ma'am.
Let me go back. Let me go back to sharing. Okay. Stop sharing that. Open share tray. Okay. Is it visible now? I need to give only give control. Okay. Can you see now?
No, madam.
No, ma'am.
I said it presenting. So am I shared? Am I allowed to present? Because I think I can present.
Yes, madam. You are presenter, so you can share.
But I'm not sure what is the problem, so I'll just stop this. Okay, now I'm back to you. Open share tray, desktop, window, lecture.
Or you can
see that. Can you see
share
now?
entire screen.
I cannot see share entire screen in my option. That is the problem. Sorry about that. Let me see. So stop this. Open share tray. Desktop window. I have screen number 1. That is the only Can
Desktop.
I don't see desktop. Maybe what I will do, I'll rejoin the meeting and maybe that would be better.
That would be better. Yeah, that would be better. Yeah.
Okay, now I have rejoined.
Yes.
And I can see desktop. Okay. So presenting, I have to give.
Yes, madam. Now it is visible.
Now it's visible, ma'am.
Allow. Okay, it's visible. Excellent. Sorry about that. Let me go back again to the lecture. Okay, so I'll go over the first few slides. Thank you for letting me know because I didn't go too far. Okay, so the lecture is on masonry materials. What we discussed, we'll talk about masonry standards, Indian and international, then about masonry units. Can you see everything and can you hear me?
Yes, madam. It is visible and.
Okay, but I see somebody else's mouse on my screen. Is it Ajay or I'm not sure. Somebody has asked to control my screen. I think it's maybe nothing. Anyways, you can see that there are two mouses. Anyways, that is okay. I think that's not bothering me. So masonry units, we'll talk about types of masonry units and characteristics of masonry units. We are going to talk about mortar and mortar types and properties, and then finally about masonry properties. So this is important because masonry units, and somebody else is going over my slides. Give control.
Madam, just stop the sharing and then share the screen. And then open the PPT.
Slideshow. Okay, so screen. Can you see now?
Yes, madam.
You can see my screen.
Yes, yes.
You can see the presentation actually.
Yes, yes.
Okay, then that is okay. So I don't need to give control to anybody. That is fine. So the only thing is somebody else went to my slides. I'm not going to give control. That's okay. So we are going to talk about masonry units, different types of masonry units, mortar and masonry properties. What is important to understand is that masonry units and mortar are constituent materials of masonry. So we have to first learn and understand the units and the mortar in order to be able to discuss the masonry properties. And that's what we are going to do in that sequence. And before that, we'll go over Indian standards, masonry standards. So Indian masonry standards are, there are several standards which were all issued by IS, Bureau of Indian Standards, BIS. The main standard shown at the top, listed at the top, is IS 1905, which is Code of Practice for Structural Use of Unreinforced Masonry. Until this year, as we discussed yesterday, that was the only masonry standard for masonry design in India. Then all the rest of these standards that are listed on this page are related to masonry materials. For example, there is a standard for burnt bricks that is IS 1077. And then the standard for fly ash bricks, IS 12894, and so on. There is also standard for mortar, for example, IS 2250, listed at the bottom, is Code of Practice for Preparation and Use of Masonry Mortar. So for any details related to masonry materials, you can refer to standards which are available free of charge. In India, we are going to refer to some of them. You don't need, for this course, certainly you don't need to read any of these standards, but it's good to know that, to be aware that they exist. Next, on international level, the most recognized standards are developed by ASTM, which is American Society for Testing of Materials. It is based in US, it's American, but it is used their standards are used internationally. These are and recognized internationally. And so this is their website. So I will mention some of their standards, and all of them start by ASTM. And then there is a standard label, for example, C109 is test for compressive strength of mortars using cubes, and then standard test for method of compressive strength of masonry prisms. So in any, the standards developed by ASTM are very well established and very comprehensive in terms of the description of their methodology of testing procedure and results, and are really among the best in the world. And in many cases, many countries refer to their standards for different testing procedures. So now we will go over masonry units. So as we said, masonry unit is a masonry element. I want you to know, it's important for you to know a term unit. So masonry unit could be brick, clay brick, fly ash brick, block. It could be stone, but in the context of confined masonry, we are going to talk about clay bricks and fly ash bricks. These are the main units that are used in India and that could be used for confined masonry right now. So clay bricks are, as you know very well, are most common masonry units in India from thousands of years ago, particularly in the area of Gujarat. You all know about all the civilizations, of course, throughout India, but in Gujarat, particularly very old brick masonry construction were found in Dholavira and other localities in the state. So two types of clay units are unburned clay units, which are adobe, and burnt clay units. So our focus is on burnt clay units because adobe are sun-dried masonry units, bricks or blocks, which are usually used in rural areas for low-rise single-family construction and housing, and are not of high strength. Although some of the burned clay bricks, as we will learn in India, are also not of very high strength, unfortunately. Clay bricks are, as the name says, are made of clay, and the chemical composition of clay is mostly 65% silicon oxide and 20% aluminum oxide. And typical dimensions in India of bricks are 9-inch by 9-inch length by 4.5-inch width and 3-inch thickness or height. And there will be another slide, I believe, showing this, but it is important in metric, in SI units, this is 230 millimeters by 115 by 76 millimeters, and it is important for you to know what are the brick dimensions. And in this photo, you can see clay brick, and you can see on the left side fly ash brick, which we will also discuss a bit later. So brick manufacturing, the quality or the strength of bricks, compressive strength of bricks, which is the most important property, strongly depends on the manufacturing process in that the way they're manufactured. It depends certainly on the source material, which is clay, but it also depends on the quality of that material, but it also depends on the process. So in India, there are 3 types of processes, and the prices are different. The simplest process is table molded process. They're called table molding bricks, with the process is called soft mud process. It's shown here in the brackets. And it is the clay which contains 20 to 30% of water by weight. So it's the maximum percentage of water. It is cast in molds, and the mold is turned upside down on a platform. And these bricks usually have a frog on one or of the bedding faces. and they're burnt in a continuous kiln known as a bull's trench kiln, most common bricks in India. So those bricks are most common, and they would be the weakest in terms of the most deficient in terms of the strength or weakest strength, lowest strength. Then the next are wire cut bricks, which are manufactured by stiff mud process. And in that case, clay contains 12 to 15% of water by weight, which is mixed, forced through a die, and cut with wire. Those bricks are significantly stronger, about twice than table molded bricks. And they are common in North America, not so common in India, but are available in India. And the third are plant manufactured bricks with a dry pressed process. And that process is clay contains 7 to 10% of water, so minimum out of these three by weight, and it is formed in hydraulic press. And steel molds are under pressure of 3 to 10 megapascals. So that is the most sophisticated, most advanced process, and results in the best quality bricks. The brick process is that it goes through stages. First is preheating stage, where green units are dried at about 175 degrees Celsius in drying ovens, which are heated by exhaust gases from the kiln. During this process, the units shrink. Then there is a firing inside the kiln from 12 hours to 3 days, and in which process the units move through the kiln, which is kept relatively cool at the entrance, hot in the middle, and cooler again at the exit. And the heat comes from burning fuel within the kiln. Usually temperatures are 900 to 1300 degrees Celsius. And then finally cooling stage from 48 to 72 hours. These units are slowly cooled because rapid cooling would cause cracking. So if you see cracked bricks, then probably they were cooled in a rapid way. These are photographs from a plant. You can see the forming process of the brick, and you can see this is how it is cut, and that is the cutting process with the wire. You can see maybe clay. This is a clay column which is cut into units, and then finally the bricks are placed on a trolleys. And then they're moved into the kiln, into the furnace, and they're fired at about 1,000 degrees Celsius. This is firing and then cooling, and they're ready for use. So these are the dimensions of the bricks, and this is an example of, I would say, probably the table brick. You can see that the edges are uneven, and that's why that is how you can recognize it. Dimensions in India are mostly 229, practically 230. You can remember 230. The other dimension you can remember 115, which is 1/2 of 130, and the third dimension is 75 or 76 millimeters. So this is 9-inch by 4.5-inch by 3-inch. And in Northeast India, dimensions of bricks are slightly larger. So the length is 250 millimeters, and then the other dimension is half of that is 125. So there are 2 centimeters longer in Northeast India than in let's say Gujarat or rest of India. So this is a photograph of a kiln from India, where these table molded bricks are manufactured mostly. Compressive strength of bricks depends on the clay, type of manufacturing process, forming, and degree of burning. So how much they have been burnt. In some cases, we can see bricks that are half burned. They're not equally burned, and it is all possible in this, I would say, simplest way of manufacturing. As we say, compressive strength of bricks is most important mechanical property of masonry because it influences, actually, we don't use, we specify the grade of bricks, but it influences strength of bricks, significantly influences strength of masonry, as we will discuss. Compressive strength of bricks strongly influence compressive strength of masonry. Compressive strength of bricks, will show you some photographs from testing. It is based on normal compression, is determined by testing it on universal testing machine, and it is equal to compression stress acting on a horizontal face. In North America, bricks are strength is from 20 to 200 megapascals, whereas in India, a minimum strength prescribed by the IS 1905 is only 3.5 megapascals. So bricks that are 3.5 megapascal strong can be used for construction in India. 10 to 20 megapascal strength is common for bricks in North India, but in Gujarat, Maharashtra, very often you will find bricks that are only minimum strength 3.5 megapascal or even less. Very often, most often, this strength is not even checked. It is specified but not checked by testing, except for larger projects. So this is a testing procedure. You can see this is actually a block, not a brick, but it has a capping, sulfur capping, and to make the top and bottom even. The same procedure would be for bricks, and then it is placed in a testing machine and crushed until it to determine the compressive strength. The classes of bricks. So how do we specify bricks? As I mentioned, there are standard for bricks, that is IS 17077 in clause 4.1. There is a table which shows classes of common burnt clay bricks, and the class designations are going from 3.5 to 35. 3.5 is the lowest, and it is related to average compressive strength not less than 3.5 newtons per millimeter square, which is megapascals, or 35 kilograms per centimeter square. We are going to mostly use megapascals in this discussion. So class, if you have brick class of 3.5, that means compressive strength of 3.5 megapascals. So this is something also that you need to know, because in order to design masonry, you need to be able to specify class of bricks and also specify mortar type. So in a construction project, you need to, as a designer, to be able to specify class of bricks or blocks, whatever. So here I'm just going to illustrate strengths of regional strengths of masonry bricks. This is based on the testing reports published in a book by Professor Jagadish, K.S. Jagadish, one of the top masonry experts in India. It's called Structural Masonry. I listed it at the end of this presentation. Unfortunately, the book is not available electronically, but it is available for purchase in India, and it is a good book. It is a summary of his very long experience. Professor Jagdish was a professor at IISc Bangalore, and he often visited Ahmedabad, is collaborating with Nirma University on some testing in their shock table, and is really a very well-known expert and top expert in India currently. So so you can see here, you cannot maybe see the top rows in this slide, but the first column shows location. The second shows type of brick, how it was manufactured, then the number of specimens tested, then average wet compressive strength and coefficient of variation, and then source, which researcher published that. So it was from different researchers, not only from Professor Jagdish, but mostly his students or colleagues. And you can see that bricks in Bangalore, for example, the first three are from Bangalore. You can see that, for example, in the second row, there are three different values. It ranges from 3.17 to 10.67 compressive strength. And the bottom value of 3.17 megapascals is related to this country or hand mold bricks, and the table value is from the table cut bricks. The other is in Bangalore, wire cut bricks, which is the most advanced. It has a value of 23 megapascals. So these are all bricks in the same area, but you can see how the strength ranges dramatically depending on the manufacturing process. Then some other areas of India, like Tamil Nadu, 8.8 megapascal, Kanpur, 19.2. They're from Professor Dayaratnam. He also published a book on masonry in 1981, but I don't think it is available. So 1920 megapascals in Kanpur, North India. As I said, it's very good quality of bricks in the Gangetic, close to Ganges River. Kerala, 10. Roorkee, also same area, Northern India, 18. And in West Bengal, it changes. So, but if you go to Maharashtra and also in Gujarat, strength of bricks is maybe very low, so it will be close to the minimum code value. So there are more values in the book by Professor Jagdish, and there are more reported values in various papers and publications. In conclusion, from the clay bricks, I would like you to know what is the class of bricks and what is the minimum allowable grade in India. For fly ash bricks, they're specified by the standard which I listed at the beginning, IS 12894. They have higher crushing strength or compressive strength than compared to clay bricks. Normally, it can be easily achieved, 10 to 15 megapascal strength can be easily achieved, and they have relatively low water absorption. They have reduced efflorescence, although efflorescence is possible also with these fly ash bricks. They have a smooth and uniform size. It requires less quantity of mortar and no plaster. I think plaster is always beneficial due to rainy season. And the density of fly ash bricks is less than the density of clay bricks. Density is in this case 1600 kilograms per meter cube, while for clay bricks it's about 1900. So lower density means lower weight. That means lower weight of load-bearing walls, and saves some transportation costs. So these are some photographs of fly ash bricks along with the pen to show how the size, and you can see that they have frog as well. So frog is this indented portion in the brick, which is usually produced for better bond properties as discussed yesterday. So here are some dimensions of fly ash bricks. They're less, smaller dimensions, so they're around 19 or 20 centimeters long, and then the other dimension is 90 millimeters, and the other two are more or less the same, 90 and 90. So they are slightly smaller in dimensions than clay bricks, but are used in the same manner with the same type of bond or pattern. Methods of manufacturing for fly ash bricks. First of all, primary ingredients are fly ash, which, as you know, is the product of thermal plants. For example, in Ahmedabad, there are some thermal plants which are close to the city and actually in Gandhinagar area, and they can be used. They have a byproduct, this fly ash, so it's environmentally friendly to use and recycle this fly ash as a ingredient for masonry. So it's I would say environmentally friendly or eco type of masonry unit. Then the other ingredient is sand and lime, and then some chemical accelerators can be added in small quantity. So this is, as I said, manufactured, product. There is a mixing stage where the ingredients are dry mixed with about 8 to 10% of water and some small percentage of chemical accelerator. And then this mixture is subjected to thorough mixing later on. And molding, their placed raw material is subjected to pressure. They're always manufactured under pressure of about, depends, but it could be a 25 megapascal in a suitable hydraulic press. And these are some examples of presses which are available in India. And then there is a drying stage where these bricks are exposed to natural drying for about 48 to 60 hours. And that depends upon weather condition. Finally, there is a steam curing where these bricks are cured in autoclaves in chambers at the desired pressure and temperature. And then after that, they're stacked in open to gain further strength for some time, but a small amount of time, like 2 days or something like that. Not so. When IIT Gandhinagar campus was constructed, there was first an attempt, an idea to use clay bricks for the load-bearing masonry, because practically all residential portion of the campus is in load-bearing masonry. As we said, it's confined masonry. So there was a need for minimum 75 grade of 7.5 grade, sorry, class of clay bricks. However, it was not possible to get the bricks of that class in sufficient amounts for the campus construction. And there was a limited time. The construction had to be completed. Therefore, a decision was made to use fly ash bricks and to set up a plant in at the campus. And I will show you later on a video how these bricks were manufactured. These are photographs from the plant. On the left-hand side, you can see the press, and on the right-hand side, you can see the bricks out of the press. And so the whole process was set up, and that plant was able to manufacture more than, I think, 1 lakh of bricks per day. So that was the need. Plus, additional fly ash bricks were purchased from some other plants. So even that was not sufficient for the needs of the campus construction. So according to ASTM standard for this type of bricks, fly ash bricks, there are 2 classes of fly ash bricks, F and C class, and the difference is mostly of the composition of the. You can see the bottom class C. The percentage of this mix of silicon, these are no chemical formulas, silicon dioxide plus aluminum oxide plus iron oxide. In case of class F, 70%. In case of class C, it's 50%. So, and then the other ingredients are more or less the same, like 5% of sulfur dioxide and so on. So anyways, the first ingredient, the first top ingredient is the primary, because it consists at least 50% of the total amount. So as you can see, it depends on the amount of these ingredients in the to define the class. So these are some chemical requirements. You don't need to remember that, to memorize that. Here is a summary of fly ash bricks for India, including the class. So the density is 1500 to 1600 kilograms per meter cube, whereas for clay bricks is 1500 to 1900. I usually take 1920 as the value, common value in India, kilograms per meter cube. And here you can see in this table class designation. It is the same manner as in for clay bricks. The class designation is actually equal to the compressive strength in megapascals. So if we say 15, class 15, that would mean that the compressive strength is 15 megapascals or 15 newtons per millimeter square. So same, that is good news, whether it's fly ash brick or clay brick, you can specify the grade in the same, or class in the same time. We call it class, not grade. And you can see the full title is Pulverized Fuel Ash Lime Bricks, or FALG. So that is the common name. Concrete blocks, I'm just going to mention them as you know, they are available in India, and unfortunately I believe that the quality is mostly not good. They could definitely be used for confined masonry construction if the strength is good enough. They could be solid or hollow. We'll talk more about hollow, and then there's a cheddar or lintel blocks. Classification is based on net or gross area. They could be fully solid with gross cross-sectional area is equal to net cross-sectional area, or hollow, where net cross-sectional area, when you deduct the holes, is less than 75% of gross cross-sectional area. So these are some examples of hollow blocks with 2 or more cells or cores, and there are blocks with 3 cells. So if the blocks don't need to be reinforced, then 3 cells are okay. But if they need to be reinforced, then 2 cells are better and necessary. But in case of confined masonry, there is no need for reinforcing blocks. Therefore, even solid blocks, which are shown also on the left diagram, could be used. So it could be solid and hollow with 2 cells or cores, and hollow with 3 cells. In Haiti, I showed you some photographs from Haiti yesterday, saying that it was very bad block quality. They all had 3 cells, so they were not reinforced, and they were with 3 cells in most cases. Dimensions of concrete blocks are also standardized, like bricks are standardized, they're more or less fixed. So this dimension B is the, as you can see at the bottom, is the width, H is the height or the thickness, and L is the length. So we have 2 types of dimensions. One is nominal, and nominal dimensions in this case for B and H are 200 millimeters or 20 centimeters, and the length is 400 millimeters or 40 centimeters. Specified dimension is by 10 millimeters less than the nominal dimension. That is simply how it is. Normally, we always refer to blocks by nominal dimensions. So the standard length is 40 centimeters, height is 20, and B width is also 20 millimeters. Here is also from Canada, from Canadian book. These are standard, and then we call it by the thickness. So this thickness, 190 or 200 millimeters, is variable. In the blocks, these 2 other dimensions, length and height, are always fixed. We only change, or it is possible to change only the thickness of the blocks in that. So there are a variety of, this is from Canada, photograph from Canada, all types of blocks that are available. You can see a variety of full-size blocks with 2 holes, then a half block, because in masonry construction we need also half blocks, and so on. And then this is the, when I talked about reinforced masonry blocks within the indentation or cuts, it's called bond beam blocks. So that these yellow circles, which are shown at the left corner, bottom left corner, they represent reinforcing bars, so that reinforcing bars can fit. That is a special block which is provided at certain locations where we want to provide horizontal reinforcement. So not every block is like this. As I said, the width or the thickness actually is nominal is 100. It starts from 100 millimeters or 10 centimeters. These are mostly for partition walls, and 125 also partition walls. 150 is the minimum that could be used for load-bearing construction, but usually it is a typical block is 200 millimeters thick. And then there are more, 2 higher thicknesses, 250 and 300 millimeters. So these are all possible block thicknesses for which are available in Canada. As I said, standard is 200, and most buildings are built using 200 millimeter thick blocks. What is interesting to see is that in manufacturing process, it is possible to create a nice texture outside, so there is no need for extra finishing. You can see on these 2 or 3 blocks have this rough texture that is done purposely. These are for exterior walls, and they don't need any finishing on top of it. So there is a pretty developed process. So in block manufacturing plants, it is so-called dry cast process concrete. You can see here the photograph. I'm not sure if you can see at the bottom. These are the blocks. They're before being, I would say, processed. So they are so-called green blocks after cutting, after forming, and they stand without being falling apart, even though they have not been hardened. So it is before hardening. So that means that the mix is very dry and the percentage of water is very, very low. There is no defined percentage of water for the block manufacturing according to the standards. It's only a standard is the standard is the strength that is required. So the ingredients for blocks are cement, aggregate, and water, and they're manufactured by vibration. And so they're vibrated, same as concrete, like you know that concrete can be vibrated, concrete structures, there is vibration and pressure. There is very high output. These plants can make like at least 10,000 blocks a day or more, and the curing is very accelerated. We know that for concrete, regular concrete construction, we need 28 days curing to harden. Here we are talking about 1 day curing, and the block is good to be used for construction. So first of all, block is, there are different mold for each shape. So if you have two different block thicknesses, like 200 millimeters and 300 millimeters, we would have different molds for those blocks. And then the blocks, after cutting, they're placed in the again in the special chambers where they're cured in accelerated manner by steam curing, like a steam chamber, and they've been dried overnight. So they're not burned, they're just steam cured, and that is that hardening that leads to a very fast hardening of the blocks, and they achieve their full compressive strength within 2 days maximum. In India also there are, and other countries, there are block making machines for field manufacturing at the site. What I showed you before, these are block plants where blocks are manufactured at the plants and brought to the site. Blocks can be manufactured at the site, but again, the question is, how good is this production process? There are good machines which can make adequate strength blocks, but these are some examples from India. Mechanical properties of blocks. Compressive strength is 5 to 50 megapascals. It could be determined over gross or net area, so that needs to be specified by the standard. You need to be careful how it is to be determined if you're involved in testing. Otherwise, it does not matter when you get the strength. You can use it, the strength value from the testing lab. You can use it for design, but for those for testing, the standard specifies, because in some countries the testing is the strength is determined based on gross area, which means we take outer dimensions of the blocks, we multiply this 20 centimeter width or thickness times the length times 40 centimeter length, whereas net area would be this gray shaded area. So that means when we don't take into account these holes. In India, the standard where you can look for the specification of blocks is IS 2185 in part 1, which gives physical requirements for the blocks. And we have different types of blocks. The load-bearing units, for load-bearing type, it is grade A block and grade B block. So you can see the A or B, and in the brackets the number. The number is that compressive strength. So you can see the typical compressive strengths for the blocks are 3.5 megapascals, 4.5 up to 7 megapascals. And for B, it is smaller, 2, 3, or 5. I believe that you can specify different if you order from the plant, but these are listed in the standards as typical strength. So maximum strength would be 7 megapascals. Here is the density of a block. Also, they are less dense than concrete. it says just greater than 1500 kilograms per meter cube. We know the density of concrete is close to 25 or kilograms per meter cube, but for B type, if it is even less. And then we have C type, which is non-load bearing unit, and it has a lower strength, so that is 1.5 megapascals. And D is a solid load bearing unit, so A, B, and C are hollow, D is solid. And D is 5 or 4 megapascals. So Indian compressive strength values are significantly lower than other countries. Usually minimum value is 10 megapascal in other countries. But in India, the lower values are acceptable right now. Because I guess that the blocks were used for low-rise buildings and or were used for non-load-bearing structures. And in that case, it is not that important what is the strength, but for load-bearing masonry, as we will discuss, it is really important what the strength is, and it has to be higher. So these were the masonry units that we covered, the bricks, blocks, and clay bricks, fly ash bricks, and blocks. Now we are moving on to the mortar. Mortar is like a glue. You can imagine it is like a glue, or it is it bonds the masonry units together into masonry, into an integral structural assembly, which we call masonry. So we call masonry wall if we have bricks or blocks, and mortar at the minimum. Mortar also seals mortar joints against penetration by air and moisture, and it accommodates small movements within the wall. So in masonry wall, it is possible, let's say, due to soil, differential soil movements, to have movements within the wall. And you will have some cracking in the wall, but it wouldn't be a significant damage in most cases if they are, if the movements are small. So mortar has certain flexibility, or some people call it even ductility, which I don't know whether it's right, but flexibility, depending on what is the composition of mortar, of course. Mortar accommodates slight differences between unit sizes. You can often see at construction sites with these hand-molded bricks, or country bricks, as are called, that they have different sizes, and that can be all taken care of after they are placed in the wall with mortar. And for that reason, in some cases, there is different thicknesses of mortar joints. A mortar also bonds to reinforcement in case of reinforced masonry, and it is important to have a proper coverage by mortar. Otherwise, the reinforcement there would be corrosion, unless reinforcement is, of course, could be galvanized or stainless steel, which is very expensive. So, but in this case that we are talking about confined masonry, we are not going to talk about reinforcement, or we are not going to consider right now reinforcement in masonry, even though it could be provided, and it is provided in some countries, like, for example, Mexico. Mortar is, as I said, is very important to seal the masonry against, or to prevent water penetration. And the mortar joints can be tooled differently if we want to have a special appearance for exterior. I'm not going to go into it. So for mortar, it is very important to be workable. Masons know what workable mortar means. That means that could be easily applied, and that's why there is no very exact percentage of water in a mortar or water cement ratio like in concrete. Mason, by experience, use the amount of water that is needed for this workability. So mortar is subjected to tension in masonry walls, tension, compression, and then shear, which is like this shear stresses, which is actually testing, putting to test bond between masonry and mortar. So the mortar needs to be subjected to horizontal stresses in order to test the bond. Key ingredients of mortar are cement, lime, aggregate, and water. Aggregate is more or less sand, but lime is optional, but very good. So nowadays, mandatory ingredients are cement, aggregate, meaning sand in this case, and water. So lime is optional ingredient. So I will go first. I will talk about two types of mortar classifications. One is by ASTM standard, which is used internationally. And I would like you to be aware of this classification, and it's actually much simpler than the classification in India. And then we will go over classification of mortars in India according to IS 1905. According to ASTM C270 standard, and this classification is used in US and Canada for sure, maybe in some other countries. The mortar types are coming from the word mason, or two words, mason work. So you can see the capital letters M, S, N, O, and K. Type N mortar is the strongest, type K is the weakest. So the types of mortars are this M, S, N, O, and K. So there are several types, but mostly for construction of structural masonry, which would be load-bearing or for use, let's say, for reinforced or for confined masonry. Type S mortar is used, which is convenient. S stands for structural, whereas type N mortar would be used for non-structural. Let's say if you are building masonry infill in a concrete frame, you would use type N mortar, not type S mortar in Canada or US. So proportions are by volume, and aggregate ratio is measured in is approximately 2.25, between 2.25 and 3.5 times. But cement and lime, cement is always mentioned as 1. Lime is 1/4 to 1/2, and then the rest would be this aggregate in according to the ASTM specification. So mortar is not usually mixed to site. On the site, it's so-called pre-bagged. So in the bag, we can buy mortar mix, which already contains everything, and only water needs to be added. That is very convenient. So we order type S mortar, it already comes in a bag, just like cement is sold in India. Very convenient. So this is again a table of listing the specification for these 4 types of mortar. I'll focus only on type S. As I said, 1 cement, 1/4 to 1/2 of lime, and then aggregate sand practically is, let's put 3. So 1, let's say 1.5 over 3. That would be the ratio of this mortar. Air content, we did not talk. We don't have time to talk much about this property. It's also important, air content. And average compressive strength, maybe you remember that, is on the order of 12 megapascals. 12 megapascals. So 12 megapascals is higher than the strength of brick in India. So this would be a high strength mortar for a brick, which is, let's say, 3.5 megapascals. And here is percentage of water. So this type S mortar, which is used for construction, is for load-bearing construction is 12.4. If you look at the type N, is much weaker, 5.2, and the weakest is type O, which is 2.4. Type O mortar is most used for historic structures where we have old mortar and we need to replace it by new. So that weakest mortar is used because old structures had also weak mortars. But for new construction, we use type S mortar in all cases. So it's very low, I would say simple, in a sense that we don't even need to know the ratio because everything comes in pre-bagged form. So that is what is mentioned, structural, non-structural. Now we are coming to IS 1905 mortar list. It is in table 1, and there are 3 grades, high, medium, and lean, or I call it low strength mortars. H, and so the label of the mortar starts with H, and then we have H1, H2. Not all mortars are shown here. If you go to the standard and look at table 1, you will see all mortars. In any case, in all cases, the mix composition is shown as one cement, then you have lime, and then you have sand. And I have created this table, so I have shown what is the corresponding mortar according to, let's say, ASTM. I would say that probably it would be correct to say that H1 mortar would be corresponding to type S mortar, but here it's shown as type M. But because for H1 mortar, which is maximum strength in India, it is listed that 28-day compressive strength is 10 megapascals, which is actually less than type S mortar. And then H2 is less. The most common mortar in India is this M1 mortar, which is 1 cement and 6 sand. So that mortar would have a strength of only 3 megapascals. So that is okay if the strength of bricks is also low. But if you require higher strength of bricks, then type H mortar would need to be used. So in any case, the summary is type H, M, and L. All of this is specified by IS 1905, and for confined masonry, same labels will remain. We are taking all labels from the all material properties from the IS 1905. So you need to have access to IS 1905 standard to understand this, or to have a list of these mortar types. So in any case, that is what it is. Bond strength is the most important property of hardened mortar. Yesterday we had some discussion about frogs and the influence of frogs in the mortar properties. So factors that affect bond strength is brick texture. So for example, it's greater for roughened surfaces or frogs, and smaller for sanded finishes. Like if we have a brick with a sanded top finish, it will have some bond, but less than if you have a frog, for example. The other property, and we are not going to talk about it here, is brick suction or absorption. So this is IRA, is initial rate of absorption. There is a test for absorption. It has to be small. It has to be limited. If it is important to control this brick absorption, or if absorption is large, it is important to wet bricks prior to 24 hours prior to laying, prior to masonry construction. You must have seen that being done. Usually it is done. In India, bricks usually have a high absorption rate, and that is not very good for the bond because they absorb water from the mortar. So, and then air content is also important for bond strength. It should be less than 12%. Higher value of air content reduces bond strength. So these tests are rarely done except at the labs, but they influence the bond. And now how bond is to be tested. So these are some indicators, but actually there are formal tests for bond. And this is a bond test according to ASTM standard. It is one of the most well-known tests for bond. This test is done in Canada. The example is from Canada, and you can see in Canada bricks, instead of frogs, they have holes. So these could be structural bricks, and they have 3 holes. So this is actually instead of, so there are 2 reasons there are holes. One is to make the bricks lighter, and the other is to increase bond between bricks and mortar. So how this is made, there are specimens made of stacked bricks and mortar. You can see that there are 4 or 5 bricks, prisms, and they're placed in this bond range, which is fully specified by this standard. So construction and all dimensions of this range or this frame, testing frame, are specified by the standard. And in the standard, according to the standard, the idea is to put weight. I'll show you on the next diagram. Oh, I have removed the next diagram. So basically the test is done that weight is put on at the bottom of this chain, which pulls this, you can see these horizontal bars, and it is like a lever. And then as a result of that, this prism is opened when the weight achieves certain value. And that based on that, we can determine the flexural tensile strength of this mortar, which determines the bond. So this is tested not by horizontal shear bond, it is by flexural tensile stress, which is an indicator of bond. It is very difficult to test the bond by horizontal shear. There are also some specimens, but they're very sensitive, and they're so triplets, they're very sensitive and difficult to achieve a reliable result. So this is actually a standard test for bond, and it is mostly acceptable internationally. It is according to this standard, and but you need to have this testing frame, which needs to be manufactured in the lab or site. Sorry, I removed those other slides showing results because of the limited time. So the most, so bond is important property, but we never specify bond. What we specify, the only property of mortar that is specified for construction and for design is compressive strength. In fact, we specify type of mortar which comes with the compressive strength. So if you say H1 mortar, we expect that it has a strength of at least 10 megapascals as discussed. So the test is done based on mortar specimens, which are 50 millimeter cubes, so similar to testing of concrete cubes, but these cubes are smaller, and they're tested in universal testing machine after 28 days. So mortar cubes are cured in the same way as concrete cubes, and in mortar strength in the wall may be higher than those tests because of this interaction of the bricks and mortar. Because what happens when mortar is fresh and the bricks have some higher absorption, they absorb water from the mortar, which actually causes the mortar strength to reduce, to increase actually, but bond may decrease in reality. So this is a placing of, according to again ASTM standards, there are specific molds for mortar cubes, and then after they're prepared in a specific way by tamping, they're cured for 28 days in a curing room, and they're tested in a testing machine, and at the end of test, the same way as concrete cubes, exactly, there is no difference. So now what is really important is this magic 1/6 cement sand mortar, which is used in India, or at least when I was a student at University of Roorkee, that was the mortar I used for construction of my model. And until now, I think this was the most common mortar type. So this is stress strain diagram for mortars, and the bottom one is 1/6 cement sand mortar. So we have 106. 1 is cement, 0 is lime, and 6 is sand. So please remember that if you don't know already. These are the mixed composition for mortar. So you can see here 3 different mortar types with 3 different compositions. The other one is 1 over 0.1 1 cement, 0.5 lime. You remember that in ASTM standards you always have some lime, and then 4.5 is the sand. And then the third one is 1 cement, 0 lime, and 3 sand. So this 103 is the strongest mortar, and this one with some lime, you can see that it has the highest strain before it fails. So it is highest ductility, as people, some colleagues like to call it. And you can see how this typical Indian mortar 1/6 cement sand is the weakest, and it has very low strain before the failure. So this is very important. This test, this diagram, and a few others that I will be showing are from the papers by Professor Hemant Kaushik, Durgesh Rai, and Sudhir Jain, published in 2007 on the tests on the Indian masonry properties, and I included that paper as a very good source for information of Indian masonry or properties, mechanical properties. For your reference, you should have received it as a handout along with this, as a material along with the presentation slides. So you can see here in the table for this weak mortar, which is 1/6, that the strength, average strength was 3.1 megapascals. Failure strain is 0.0087. That is not dimensional. This is modulus of elasticity. We're not that interested for modulus of elasticity of mortar. Strong mortar, 1/3 is strength is 20 megapascal, which is about twice the strength that H1 mortar is needed. We remember H1 strength 10 megapascals, and intermediate is 15 megapascals, which is again very high strength, much stronger than required by this H1 type of the mortar. So that is important. So for mortar, the way that was all I wanted to say about mortar. As I said, there are some other properties, maybe more details about bond, about this air content and all that, but we are not going to talk about that. We are focusing only on the properties that are relevant for our design for the course, but there could be more. Normally my lectures on masonry materials are longer than this. So for mortar, I would like you to know what are the types of mortar in India and what are the types according to ASTM, and which types are used for load-bearing masonry. And today, at the end of this lecture, you will see what is required by the Indian standard for confined masonry. Not all mortars are allowed for that, and not all brick or masonry unit properties are allowed. Now, final topic in terms of the description is mechanical properties of masonry, and our main focus is compressive strength, which is called F'(M). So this F'(M) is equivalent to FCK, F sub CK for concrete. So this is the property that will be used for design. So we always need to know somehow, or assume what is the F'(M) for the masonry in order to be able to design confined masonry structure, wall, for example, which we will do. So this is the most important mechanical property of masonry, since it is most intimately related to resistance under load and serviceability and durability. It is not, what is very important to understand, that this strength is not the sum of strengths of individual components. It is not related to it is not combined strength of mortar and combined strength of bricks. It is not equal to that. So because when we apply, so the strength of masonry is determined on the prisms, which are made of bricks or blocks and mortar stacked, like I've shown you for bond test. So 5 bricks and then mortar. In that state of stress, when that prism is subjected to compression in the testing machine, bricks are usually in 3-dimensional state of stress, as shown here in the middle. And you can see the tensile stresses. There is compression coming from vertically, but horizontally, they tend to expand, and there are tensile stresses in both directions. And for mortar is squeezed between the 2 bricks, and mortar is under triaxial state of compression. So there is different state of stress in bricks and mortar. And then these other 2 are brick unit tests and mortar cube tests. But our focus now is what happens when we test masonry prisms, and this test is giving us F'(M). So here are some photographs from the paper by Kaushik, Rai, and Jain, which I mentioned and which you have. This is brick unit. You can see that how it is, the frog needs to be fully filled before testing. Mortar cube after testing. So this is brick unit after testing. And here are masonry prisms after testing. You can see that this masonry prism has a vertical crack along this shorter side, and you can see that it is crushed. Why vertical crack? Because if you look at it, there is a tensile stress which is going in this direction, tensile stresses which are trying to separate this, to pull apart the brick and that's why there is a vertical crack in the prism. So that is expected to see at the end of the testing. This value of F prime M can be evaluated by compression tests on masonry prisms, and design of masonry elements can be based on the specified compressive strength of masonry, whose role is analogous, as I mentioned, to that of specified characteristic strength of concrete. So we need to get this strength either by testing or by specifying the strength, the class of brick and mortar type according to IS 1905 standard. So, and I will show you how to do that at the end of this lecture. So what are the key factors that influence masonry compressive strength? Masonry unit strength is number one. It influences to the maximum extent. Mortar strength is the second. In case we have block masonry, then grout strength, grouted versus ungrouted, again, a case of block masonry, and directional compressive stress relative to the bed joints, that would be, so these three factors are critical for brick masonry: unit strength, mortar strength, and directional compressive strength relative to the bed joints. I will show you what it is later, but these first two we will discuss now. So if you have, this is conceptual stress strain diagram showing on the same diagram stress strain for masonry unit, let's say brick, grout, forget about grout, and then strength of masonry prism, and this is strength of mortar. So you can see the strength of masonry unit will be the highest, strength of the mortar is usually the lowest, and strength of the prism will be somewhere in between. So strength of prism or strength of masonry is in between the mortar strength and masonry unit strength. So if compressive strength of masonry units, we have stronger bricks. We are in northern India and we have 20 MPa bricks. F prime M is going to be higher than F prime M in Gujarat, where we have lower strength bricks and we use the same type of mortar. As far as mortar is concerned, lower strength mortar will result in low prism strength, but there is, I would say, a myth that mortar strength is important and the percentage of cement is more important than bricks. So that is not true. Actually, it's more important to have a higher strength bricks. Thickness of mortar with respect to thickness of unit. This is important in India. You could see that in some cases mortar joints are thicker. Normally it should be 10 to 12 millimeters, but in practice you can see 20 millimeters or more. There is no benefit of it. It is a waste of mortar and it can result in a lower masonry strength. So there are some tests to that effect, but I'm not showing the results. Mortar type, as I said, these are now shown with the ASTM types. The higher mortar, the higher strength of mortar influences the strength of masonry, as I said. That is there. But the question is how to determine compressive strength. We are coming now to the way that we are going to determine for the course. One way, and that is how it is specified by Indian standards as well. One way is to do a prism test where at least 2 to 5 units are stacked together and tested. And the other is a knowledge of the unit and mortar strengths or assumption. And based on that, we determine F prime M. And the third is in field test. If you already have a constructed wall, you would need to take samples from the wall. But for new construction, we have options 1 or 2. Either do a prism test at the site for larger projects. For example, at IIT Gandhinagar project, these prism tests were done, or have a knowledge of this. So the strength of brick of masonry is determined based on the net area of the horizontal area of the bricks, and there are some correction factors depending on the height to thickness ratio. Height to thickness ratio of the prism that could reduce the strength or increase depending on what is the ratio. That is all specified in IS 1905. So since the full area of the unit is not loaded, that is only for concrete. Is the strength of masonry lower than the strength of unit is that there are different values of Poisson's ratio, that Poisson's ratio for the unit is higher than for the mortar. So the mortar is confined and its strength is enhanced, but those difference in strength in Poisson's ratio are making a difference in the strength of masonry and strength of masonry unit. So here are some results again from the work by Kaushik, Rai, and Jain. You can see that they tested actually 4 brick strengths. One type of brick strength was 16 megapascals. B bricks, M bricks are maybe 18, S bricks are about 20, and then O type bricks are more than close to 30 MPa. So these O-type bricks are very high for India. So you can see here the influence of prism strength depending on the mortar type. So you can see this 1/6 type mortar, and you can see how it changed depending on the brick strength. So if brick strength changed from 15 to 30, you can see that there was a change in the mortar, in the prism strength, but it is not twice. If you have a higher strength mortar, the change in the strength of prism is very small depending on the what is the difference in the height of, for the same mortar type, it was a smaller difference in the prism strength. So for this 1/3 mortar and 1/0.5 and 4.5, the type of mortar, it's very flat. It's not very steep curve for the depending on the brick strength. This is another way of showing it. This is the variation in mortar strength on horizontal axis at the bottom, depending on the brick type. So you can see that for 1/6 mortar, which is the lowest, you can see the largest variation in the strength, prism strength, depending. That is actually same information from the upper diagram. So I think the conclusion is the same. In any case, F'(M) increases with brick compressive strength, and F'(M) increases with mortar compressive strength. So both are important, but I would say bricks are more important, particularly for lower strength mortar, as you can see on the upper side diagram. So you can see that for 1/6 mortar, it changes maximum depending on the brick strength. The F'(M) changed in a maximum way, much larger extent than for the other values. So here are some prisms. As I said before, the IIT Gandhinagar campus was constructed. The testing of fly ash and clay bricks were done at IIT Kanpur campus by Professor Durgesh Rai and his team. So you can see the test specimens of clay bricks and fly ash bricks. The reason I'm showing you here is to get a sense what was the values of F'(M) for clay bricks. The values they were getting with using the local bricks from Gujarat were 3.8 megapascals for 1/4 mortar, one cement, 4 sand, and 3.9. So very small difference for the other mortar, which is weaker in reality. 1 cement, 1 sand, and 6. One cement, 1 lime, and 6 sand. And so 3.8 to 3.9. Whereas for fly ash bricks, the strength F'(M) was in the range of 3.5 to 6.8 megapascals for 1/4 mortars, so same mortars. So maximum values were 6.8 and 7.3, which are significantly higher than 3.8 or 3.9. And based on that and for more extensive testing too, Other testing, it was possible to decide to use fly ash bricks for this. And here you can see this vertical, these clip angles and instruments. This was for measuring stress strain strains. So not only stresses, but strains were measured. That's how this they obtained those diagrams. In terms of elastic, the next property besides compressive strength is elastic modulus of masonry. And it has to be obtained by prism testing, or there is a formula. Elastic modulus based by prism testing is obtained by stress strain diagram. It is a slope, as you know from the Hooke's law. It is a slope on the stress strain diagram in the range of 5% to 33% of F prime M. So this is a stress strain diagram of masonry. F prime M is the prime is missing here, is the maximum strength. I would also like you to know the shape of the diagram. The shape of the stress strain diagram is parabolic, and the maximum value is F prime M. And the slope of the stress strain diagram in the range, low stress range, from 5 to 31/3 of the F prime M is giving us EM, which is the modulus of elasticity of masonry. That is important parameter for design, because in any numerical model you need to have modulus of elasticity. So the tests that were done by, again, the same group, Rai and Kaushik, Rai and Jain, showed that for Indian bricks, the average value was about 300 times this is for clay bricks. That the brick mortar modulus of elasticity, which we are not interested in, but just in case, it's 300 times the brick compressive strength. For mortar, it is 200 times the mortar compressive strength. But for the prism, so please look at the red text, that is what we are interested in, it is about 550 F prime M. So if you have F prime M of, let's say, 10, then the mortar, the EM would be 5,500. This is all in megapascals. So please note that. So these are three values. These are strength for masonry prism specimens. You can see at the bottom, E is 550 F prime M. You can see a large scatter of results, but anyways, this is the best, and this is the accepted value by most standards, masonry standards. In current Indian standard, or the past Indian standard IS 1905, there is no this value, but it is included in the new standard for confined masonry, because this value, you need to have it. So, and then these upper two diagrams are for bricks and for mortar. So these upper two values you will not need in design. The lower value you will need in design. Another value which I'll mention is shear modulus, and it is determined as a ratio of E value. I will show you what the standard says for that, but I'm just showing you results of experimental testing. Please note a large scatter of results for these E values, but anyways, that is how it is. Recommended values for brick masonry are definitely 550, like it was obtained by this testing, but the range is between 550 and 700 in general. And I think all you need to remember or use is 550 for the test. Elastic modules by prism test, that is, these are different types of, I think there is no need to go there. Last test that we are going to show is diagonal compression test for masonry, which determines the prism, which determines the strength of shear strength of masonry. We talked yesterday a little bit about shear strength of masonry, and we will talk a lot because we will be using it today in the second lecture, actually. So we need to know what is the basic shear strength of masonry. How do we determine it? One way is, as I said, by equation, as a fraction, as some relationship with the compression strength, which is F prime M. But the other way is to do the testing. So how does the test look like? On the left diagram, you can see masonry wall. That's imagine it's confined masonry wall. You have shear force V. You have a normal axial load N. And when you apply this shear force V in combination with axial load, there will be a crack which will develop in the wall due to the shearing effect of this force V. So this is a shear stress. And if we rotate now this wall, imagine that you can rotate it by 45 degrees, you would get this specimen shown on the photograph. And of course, it is not practical to test full walls like that. Therefore, the standards, and there is again ASTM standard for that, which specifies the size of this specimen, and it is tested in universal testing machine by a compression, applying compression. And the value of the shear strength is obtained when the first crack develops along this specimen, vertical crack in this case, because the specimen is rotated, and that is so-called diagonal compression strength, which is basically the basic masonry shear strength. So these are specimen sizes. This is a ASTM standard E519, which requires that. I recall that when I visited Nirma University last time, they had this set up for the testing, which is great. And then these are some tests done at IIT Roorkee by Sachin Kadam. That was part of his PhD thesis. So that is the specimen before and after the testing for brick masonry, and he got these values of the strengths of shear stress or shear strength. So maximum value, just for your sense, this is half brick thick specimens and this is full brick thick specimens. They're on the order of 0.2 to 0.3 megapascals. So it is much smaller. If you recall, we were talking about what is F prime M for Indian, for let's say IIT Gandhinagar. I think I hear some noise. Maybe please mute yourself if you're not speaking. No, I mean, I will take questions. I'm almost done with the presentation. So, in this case, we got 0.2 to 0.3 megapascals, and compressive strength of masonry in this case was 3.5 megapascals. So you can see roughly that the shear strength is less than 10% of the compressive strength. And we will use shear strength for determining shear resistance of masonry walls. And these specimens, just for your information, are made from this M1 mortar, which is 1/6 cement tense mortar. This is the PhD thesis of Kadam from 2015. And these are some values of the maximum shear stress. You can see it is around 0.2. That is from his testing. In a confined ERI confined masonry guide, which I mentioned yesterday, and I suggested that you download, we can also share if you haven't downloaded it. There are recommended values based on Mexican experience, and the suggested values are of for the lower strength mortar, which I would expect in India, is around 0.3. So the value to remember for the bricks for this is on the order of 0.3 maximum. So for solid crate bricks, for the other are hollow units and the solid blocks. So I would say 0.3, between 0.2 and 0.3, not more than that, will be obtained for Indian masonry strengths. So this is important. This masonry shear strength is labeled as VM, and that is how it is mentioned in the code as well. So VM is small letters because it is stress units in megapascals. Now I will talk about design methods that are used in the code, and then I will show you those tables, I include them at the end, but that is how it is. So two types of methods are used. In fact, maybe I can skip through that and then go to the tables. So I'll skip these two slides and then come back to them later. So when we test masonry, or no, actually I'll go back because I have a reason for going back. As you know, for any material, we have this is important for the further discussion. We have two types of design approaches or design methods. One is allowable stress design, ASD, or known as working stress design method. And the other is limit state design method or ultimate limit state design. As you know, if you know IS 1905, it is all based on the allowable stress design method. However, if you go to concrete code, to steel code, you are using mostly limit state design, isn't it so? Mostly limit state design nowadays. This is a modern design method. In developing Indian standard for confined masonry, both methods have been used. My focus in the course will be on limit state design. I will not use allowable stress design at all, but in the code, both methods are used and equations for according to both methods are used. The idea is to use more limit state design, but both methods are permitted. In terms of this is just to mention, you have also in the code, and these combinations are not known. They're the same as, let's say, for concrete. In the limit state design method, as you know, the way to design is to apply, to increase the loads by load factors. For example, in earthquake load combination, we have 0.9 dead load, and they are at the bottom 4A, 4B, and 5. 1.5 dead load and 1.5 earthquake load, or 0.9 dead load and 1.5 earthquake load, or 1.2 times dead load and live load and earthquake load. These are the combinations for limit state design. So we increase the loads, and then we apply, in calculating the resistances of the structural elements, we apply some reduction factors for materials because we want to be realistic. So, but these are load factors, and I'm not going to repeat this again because, as I said, these are the same as you would use for concrete structures. They're also listed, I believe, at the beginning of the masonry, in the confined masonry code. Now, why this is a basis? When it comes to material properties, you know that for the limit state design method, you have partial safety factor for concrete, for steel, and for masonry. For masonry, this factor is 2. Gamma M for masonry is 2. If it was concrete, 1.5, for steel, 1.15. So the inverse of material resistance factor, which is used in American and the Canadian codes, for example, is 1 over gamma. So you basically divide by this value of 2. So it is the same as if you were to multiply the strength, let's say compressive strength, by 0.5. So you take 50% of compressive strength off in this approach. That is for limit state design approach. According to IS 1905, they give safety factors, and the safety factor for masonry is 4. So you will see why this is used now in the further slides. So the question is, if IS 1905 gives us all values for masonry according to allowable stress design, how do we get F prime M? That is the question. So for that reason, we need this framed area. And this is now new in the code. That is what is not. So in the code, this is now from the confined masonry code. This is stated just for engineers to remind engineers that if we talk about design strength, we take the ultimate strength and divide by gamma M. That is what I said. If gamma M is 2, then it is the same. You divide by 2, it is the same as you multiply the strength by 0.5. So, and it says, that is the direct statement from this, that this value is 2 for masonry, 1.5 for concrete, and 1.15 for steel. Now, in the IS 1905, as we said, there is a way to determine allowable stress or ultimate stress based on the knowledge of the class of masonry and mortar grade, mortar type. So if we have, let's say, in this is table 10 from IS 1905, which gives basic compressive strength for brick masonry. So this first row is giving us all these classes of bricks, 3.5, 5, 7.5, 10, and it goes all the way to 40. In the vertical column, in the column you have a type of mortar, H1, H2, M1, M2. I created this table just as extracted from this IS 1905. For example, if you have 10 MPa brick strength, let's say we have relatively good bricks given for local conditions in Gujarat. They are really good if you have 10. Then if you use H1 mortar, allowable brick basic compressive strength is 1. But that is not what the question is, what is F prime M? So then we go to the next table, which is giving us F prime M. How do we get F prime M? By multiplying the basic compressive strength by 4. Why 4? Because we said the factor of safety is 4. So we are going inverse method of calculating it instead of dividing F prime M by 4. To get allowable stress, we are multiplying by 4. So the value of 10, if you have 10 MPa bricks and H1 mortar, is now 4. So F prime M is 4 if you have 10 MPa bricks and H1 mortar. That is how it is going to be used. So this table is very useful, or you can just use the basic table from IS 1905 and multiply by 4. It's up to you. So this table is in one of your slides, and you can use it for design. And that is according to the code. So this is the equation, F prime M is 4 times FB. Now we are coming from few requirements. Yesterday, one of you asked a very good question. How is masonry code or confined masonry code in India different from confined masonry codes in other countries? One of the differences is what is the compressive strength that is allowed. In section 5.1.3 of the code, it says that the minimum compressive strength of masonry units used for confined masonry buildings up to 2-story shall be 3.5 megapascals, and for more than two stories, it shall be 7 megapascals. For concrete blocks, minimum compressive strength shall be 7 megapascals. So the standard allows up to 2-story height to use the minimum strength bricks, but if you want to go more than 2 stories, it is necessary to use 7 MPa bricks or bricks. Yes, for blocks it is 7 MPa. For this section 5.1, so section 5 in the standard is on materials. Section 5.1 is on masonry units, and it says that it could be bricks or blocks could be used, and these are types of units. So you can see that it specifies that, but what I circled is these requirements. So you cannot specify, let's say if you're doing, I would say even for 2-story, I would take 7 MPa bricks, and you will see the reason. The reason is the amount of walls that you will need to design the wall thickness will be higher if you use lower strength bricks. You will see that in the next lecture. Next topics covered by the standard are the mortar. So you can see here that it says that only 4 types of mortar out of all that are available according to IS 1905 are M1, M2, H1, and H2. So only 4 types of mortar are permitted. And it talks about wood mortar and all that. So you can see that only these 4 types of mortar. Then next is F prime M, specified compressive strength of masonry. In the definitions in 3.10, where the definitions part of the code, it says what is specified compressive strength of masonry, and I would like you to know this definition. Compressive strength of masonry expressed as a force per unit of not cross-sectional area required of the masonry unit in construction by the contract document and upon which the project design is based. Whenever the quality is under the radical sign, the square root of numerical value is intended and has the units of MPa. You will use that. So specified compressive strength should be determined by the testing of prism specimens, and the absence of test values. Values for the specified compressive strength should be obtained by multiplying permissible compressive stress according to IS 1905 for the combination of masonry unit strength and mortar type by the factor of 4. You see, that is what I've shown you on the table before. So, and finally, elastic modulus, or modulus of elasticity. It says in the standard that for clay masonry it is 550 f/mm, and for concrete masonry is 850 f/mm. Shear modulus for concrete it is 0.4 modulus of elasticity. For masonry, the tests have shown, because of different Poisson's ratio, that is 0.2. So this is important to note because you will also need shear modulus for some calculations in numerical models. So it's different than for concrete. So please note this because it's important for further analysis and design. And in this standard, we also have the shear strength of masonry, which is defined in the definition section. It says it is shear force resisted per unit or not cross-sectional area of masonry determined by a diagonal compression test of masonry or a function of compressive strength of masonry. So Annex B in the standard describes this test. It actually encourages this test to be done. Obviously, it's not going to be possible, and explains how it is done. It is mostly taken from ASTM standard, but it shows the specimen type. So all this that I've shown you before is shown there. And for further reading, my suggestion is to read the book by Professor Jagdish. I mean, to have it as a reference for Mason. If you're interested in Mason, you should get that book. I hope it is available. It is published in 2015. I have a copy. Professor Jagdish was kind to give me a copy, but we purchased a few copies for IIT Gandhinagar. And then a paper by Kaushik, Rai, and Jane, which I shared with you, and this is the full reference to that paper, which is also available online, but not free of charge. So that would be all. Any questions from your side? I will stop sharing the screen. Stop sharing, maybe. Okay. Okay, I stopped sharing. Thank you for your attention. Any questions that you will have feel free to ask about these properties. Maybe this is not the most interesting lecture, but it is necessary. I will put it that way. It's really important to know masonry properties in order to be able to design and to know what you're designing. Yogesh, question? Please go ahead.
We have talked about in-plane loading, and tests about in-plane loading. So what about out-of-plane loading and strength
we have not talked about any loading, but we talked about masonry properties. But what you are referring to maybe is for this diagonal strength for in-plane loading. We will be talking in the course regarding out-of-plane loading as well, but we are not talking about loading. We're talking about masonry properties. So whether it is in plane or out of plane loading, basic properties are the same. They don't change. So we determine the basic properties. If you have concrete under out of plane, do you have different FCK?
No.
So how would it be for masonry?
I mean to say, is there any bending test for flexural test?
There is a flexural test, but not for the full walls. I mean, you can test the full walls for under any loading, but not the basic test for materials, because there is no flexural strength of masonry. You still use the there is that bond test that I've shown is giving you flexural tensile strength. That is already giving you for text flexural. So all you're interested is flexural tensile strength, stress, and the interface of bricks and masonry, because for out-of-plane loading, we are talking about kinematic mechanisms, and they're not really dependent on the strength. They're just virtual work principles. It works completely different than that. But in any case, just think of concrete. You don't have any different properties. So we were just talking about masonry materials, masonry properties. which you will use for further design for in-plane and out-of-plane. We have not even come, our talk on in-plane and out-of-plane loading will be on Thursday. So this is properties that we will use in that design. That was the scope of this lecture. And diagonal shear test is used only for in-plane. That is absolutely true. When we want to determine shear strength of masonry wall in plane, then we will use this value obtained through the testing, or as we will see, code gives equation if it's not possible. In many cases, it will not be possible to do the testing. Then we use equation. But for out of plane, as I said, whether it's in plane or out of plane, the same masonry properties are required. And there is no difference there, but out of plane resistance of masonry walls is a separate topic which we will cover on Thursday. Due to out of plane seismic loading, that's what you meant, or wind loading for that matter. Okay, hopefully that answered. Any other questions? Okay, I know that they've gone a bit longer with this lecture and I had some trouble. I would like to show just for the end, oh, one more maybe. Let me see. No, that was the other.
Yeah, ma'am. Can I go ahead with my question, ma'am?
Yes, please, yes.
Yeah, ma'am. This question is that when you talked about the table of IS 1905, so there you have this mortar strength versus the brick unit strength, which gives you compressive strength of the prism, like, you know, if you are not for prism testing. So my only question is, ma'am, since I am also working thoroughly on masonry, what I've come across is that these days the mortar strength goes very high because of the strength of the cement, which is increasing, right, with the basic constitution being changing. So in that case, the basic compressive strength of the masonry is also on a higher side in comparison to what is given in IS 1905. So does that affects in any way the design of confined masonry?
Well, that is a very good question. Unless a new table is created based on the testing, extensive testing that's done in India, there is no other table right now for the masonry strengths other than what is in IS 1905. So an option would be that for a project, masonry prism test is done. So if you do prism test, then you're not tied to this table.
Okay. And
see, that is an
alternative.
So if you do big project like IT campus or something, you know, like not just single building, but some larger project, a complex of buildings and things like that, then I would suggest always to do the prism test, and then you determine the strength. You're not tied to that table at all.
Correct. Okay, ma'am. My second question is, like, you have been constantly reiterating through your lecture that the compressive strength of the brick unit is very, very essential when it comes to confined masonry. So what I get from this is maybe that if you have a strength more than 7.5 megapascal, that is sufficient enough. Now the thing is, ma'am, you mentioned about modulus of elasticity, which is some fraction of the compressive strength. So let's say that we get the basic compressive strength of brick unit as more than 7.5 megapascal, or maybe even more than 15 megapascal. But if the modulus of elasticity formula doesn't fit in, is that okay? Like you mentioned that for concrete masonry, it has to be 850 times FM.
That's right. So these tests were done, Poonam, based on the extensive variation of, you know, properties of bricks, mortar, and all that. And so far, this value is accepted by all the codes. Let's say in Canada, where the brick strengths are much higher than what it is, it's also 550. So that is same as what was obtained by this testing. So I would say that colleagues from IT Kanpur, they actually adopted what was already in the codes in other countries. So it's not, it is in the code. So it is simply fraction proportional to F prime M. So what comes into F prime M depends on the combination of bricks and mortar. So, but ultimately, that is at this moment, this is the best relationship we have. So I think, and you know, from the perspective of the importance of that, looking forward to the design, it doesn't matter that much if you have the same, you have the same bricks, the same mortar in throughout the building, so it will not make a difference. So modulus of elasticity, as you know, is mostly affecting displacements. And if you have, let's say, smaller or larger, it will be different displacements. But in masonry structure, displacements are so small that barely matters. So in this case, luckily, it does not matter that much, but that value of 550 and 850, these are the accepted values in most international codes. And those are the countries which have much higher normally strengths of bricks and also mortar. So it is, as you could see, and you probably know if you're looking into it, there is a huge dispersion of values for this EM. So certainly, again, the best thing would be to test prisms and then to get modulus of elasticity from the stress strain diagram. But then it is a complex testing. It requires strain or displacement measurements and all that. So I don't think it will be routinely done in on the projects. Maybe in the projects prisms will be tested, but I would say only in the labs, let's say your lab or labs at other colleges, universities, they may test the strain. So, but it would be interesting to test that type of testing is really important. I feel that more testing of that type should be done in India, considering that simply the strengths of bricks are still different than what is in other countries. And so more tests were done in Canada, USA, but the strengths of bricks are much, much higher and mortars are different. So country-specific testing needs to be done to get information. And I fully agree that values in IS 1905, I think they are there from 1960s or 70s, I guess, something like that, many years ago, done many years ago. And it is time to update it, but however, that standard is not being updated substantially for many years, as you very well know, since you're working in the field of masonry.
Yeah, thank you. Thank you very much, ma'am.
You're most welcome. Any more questions? I would like to show you a very short video showing how the fly ash bricks were made at IIT Gandhinagar campus. I didn't record it. Somebody else, in fact, I recorded also. So I'll try to share the screen and if I can make it work. It's a large video. I will not be able to share with you, but I'll share just a small portion of it. I will not be able to share with you electronically. It's like 200 megabytes. Let me see if I can share desktop. So I'm not sure if I think I could go to my slideshow. Okay. Can you see my screen now?
No, not yet, ma'am.
Hello. Sorry, I think I was out of the meeting. Can you hear me?
Yes, madam.
Okay. So I'll just go to share desktop. Let me just see. Can you see my screen now?
Yes, madam.
Okay. So these are bricks. And now I'll show manufacturing. So anyways, that is what I wanted to share. I will now go and stop sharing. Okay, so that was it. It's a bit longer video. I was not able to edit it. In case Professor Poonam is interested, or we can maybe share, and you can crop it off if you want to show to the students. That plant has been dismantled after the first phase of construction was done, so it does not exist anymore. But I'm sure there are other manufacturing plants in Gujarat. I know that there are, so you can visit one. So anyways, any other questions? I believe we have another link for the next lecture, isn't it? So it's a different link. Any questions? Can you hear me?
Yes, ma'am. Yes, ma'am. You are audible, and I guess there are no questions from the participants. And if at all they are having any questions, they can ask at the end of second session also.
Yes.
So
Second session is going to be shorter. Second session is going to be shorter in terms of the number of slides. It's much smaller, but there will be more explanation. Now we are coming to seismic design. So for those of you who are, I know all of you are interested in that, we are coming to that. So this was just one of the background lectures that is giving us setting for the rest of the course. So now we're going to simplify design and discussion on the assignments. Can you please confirm, Chaitanya, have you shared the assignment with the students yet or not?
Not yet. I will share today.
Okay, so if you, because I'm going to discuss, so you're going to share the assignment that we discussed already, you and I.
Yes.
Okay. Because at the end of this,
I'm sharing right now. Yeah.
Why don't you share it right now? Because after this session, next lecture, I would like to discuss with you, the students, the assignment. So I think it's a good idea if you share, because it is also related to this lecture, the second lecture. So I will rejoin you from my tablet, from iPad for the second lecture, because it will be better that way. And I hope it will work. So if it doesn't work, I will reconnect this way from the computer. But so we are joining in about 10 minutes, or can you please confirm the time we are joining from now?
It's fine.
Can you please
Yes, ma'am. We'll take a break of 10 minutes and then again we'll meet.
In 10 minutes?
As per your convenience.
And different link also. Different link. Okay. Thank you very much for your attention. I hope you have these slides, and the materials are already with you. And for the next lecture, also slides